Here we are on section 5.3, and we are going to find the general solution for this, and then we're going to find all the solutions. So what we're asking here is, where is the sign equal to this? Well, if we go back to our unit circle, we know that the sign is the y value, and our y value is going to be equal to that at that place and that place, at those two angles. And we know those two angles are 4 pi over 3 and 5 pi over 3. And so that's what the two, if we said from 0 to 2 pi, that would be our solution. But, well, we don't want to have a bracket on both of them. We want parenthesis on one of them. But when they talk about finding all the solutions, we know that if I had 4 pi over 3 and I add 2 pi to that, then I would have the next lap around, I would get back to it. But to say all of them, I can add 2 pi n, and so then you get, if n is a negative, then we're going that way around, and if n is positive, we go this way around. So if I wanted to say all of them, I would say 4 pi over 3 plus 2 pi n, and 5 pi over 3 plus 2 pi n. That gives all of them. So most of the stuff that we're doing in this section is we're solving trig equations. We're finding out where they're true. So we're going to simplify as much as possible using factoring and our algebraic techniques. Now we can work on both sides of the equation because we're done with that section. So just remember that that section is over, so now we can do some of these things. Remember, the period of sine and cosine are 2 pi and the period for tangent is pi. And remember that some equations do have no solutions. We can't have sine and cosine above 1 and below -1. We can't have those because they're still undefined there. And those solutions are extraneous roots. When you divide both sides of an equation by some trig thing, you're going to lose solutions, so don't ever do that. That's a naughty naughty. Okay? Let's get to a couple examples. For instance, if here I divided both sides by cosine, it would just go away and we would have nothing. It wouldn't make sense. So what I'm going to do is I'm going to subtract, which is okay. Subtraction is okay on both sides, and I end up with 2 cosine of x equals the square root of 3. Divide by that 2, divide by the 2. And so we are looking for where the cosine is equal to the square root of 3 over 2. Again, go to your unit circle. Cosine is an x value, so we're looking for values here and here. Notice that I put this line at this square root of 3 over 2. It's one of those common numbers that we know. And we know that it's hitting it at square root, or pi over 6. And down here at 11 pi over 6. Now again, we're not using the inverse cosine limitations, so I'm not saying pi over 6 and negative pi over 6 here. Our intervals that we're working with are from 0 to 2 pi. Hey, look, it's the same answer. So here we have a squared thing, so I'm getting pretty fancy here. Let me do a little bit of solving. And divide by 3, divide by 3, and I get the tangent squared is equal to 1/3. When I square root in an equation, I know that I have to put a plus or minus in front of there, and so I get 1 over the square root of 3. If I rationalize, you might recognize root 3 over 3. And it's plus or minus, so don't forget about that. So if I go to my unit circle, we know we have there, 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 where the gravity is pulling them, right? So we have the pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 are all the values. When you get a squared thing in here, you're going to have more answers. Hey, look, same answers. All right, so we're never going to divide, so you're not going to divide both sides by sign. So what we can do is we can get everything on one side and minus square root of 3 sine of x equals 0, and then factor out that sign. So I have the sine of x times the quantity of 2 cosine x minus root 3. And so in this case where we have two, this is the first one where we've had two different trig things. So when we get to this point here, we know that the sine of x has to equal 0, or 2 cosine of x minus root 3 has to equal 0. One of those two has to be true. They don't both have to be true at the same time, but they are both true. So we're going to find the sine of x is equal to 0. Sine is the y. And so I know that happens at 0 and at pi. Over here, I'm going to solve it. Add square root of 3 to both sides, divide by 2. And I think we've talked about where the x value is equal to that. And that we said that was pi over 6 and 11 pi over 6. So we get 4 answers. Feel free to pause any of these. Oh dear. Oh geez, somebody was going to yell at me because it says degrees here. 0, 180, 30, and 330. Whew, good thing I caught that. Alright, hey, look at that, same answers. Alright, over here. Now, when I said we could use factoring in here, if I was to rewrite this as x squared minus x minus 1 equals 1 and solve that, I bet you guys would all be able to do that, factoring that into x minus 2 and x plus 1. Well, this is no different. We just have to recognize it as being a trig trinomial, so we can factor it the same way we did. So I'm going to do the same thing I did when it was a variable. Get it equal to 0. And now I'm going to factor it into sine times sine and minus 2 and plus 1. Well, I know that the sine of x is never equal to 2, so we know that there's no solutions from that one. Over here, I know that the sine of x is equal to negative 1. Sine is the y, and that's equal at square root of 3 over 2. So we had a possibility of 4 answers with the square in there, and yet we only got 1. Hey, look at that, same answer. Now we have something with 2 different trig things, and it looks a lot more like the stuff that we were doing in section 2, but we can still use some of that stuff. Let me start it out. Now, we know that the cosine is equal to 1 minus the sine squared. Now, remember, we're not in section 1 anymore, so I can do this stuff. If I subtract 1 from both sides and add a sine squared to both sides, I get 2 sine squared x minus the sine of x equals 0. If I pull one of those signs out front, I'm left with 2 sine x minus 1. And so we know either the sine of x equals 0, or the sine of x, move that to the other side, divide, is equal to 1/2. Now we know that the sine is the y, and y is equal to 0 at 0 and pi. We know that the sine is the y, and it's equal to 1/2. There there and there. And so I'm going to say pi over 6 and 5 pi over 6. You can get those off your unit circle sheet. And let's see if we have the same answers. That was it. Oh, I'll be darned. Same answers. All right. Now, how do we deal with this? Well, one of the methods for dealing with this is we could move one to the other side and say, well, when is the sine equal to the cosine plus 1? And we could look at those, and we know that's true when the cosines are negative and the sines are positive. So we're talking about places like the second and fourth quadrant where they're opposite signs. But then you're just looking up and trying to find those. So another option, let me erase this, another option is to square both sides. But you remember from before, anytime you square both sides of an equation, you can be introducing extraneous roots. So we have to be careful of that. And I know that sine squared plus cosine squared is equal to 1. So I'm left with negative 2 sine x cosine x plus 1 equals 1. So 2 sine x cosine x is equal to 0. Dividing both sides by negative 2 still gives me 0. So either the sine of x is equal to 0 or the cosine of x is equal to 0. And the sine is the y. We know that happens there and there. We've seen that. When the x value is y, we get the pi over 2 and 3 pi over 2. But wait, we're not done. We know that when we squared both sides up here, we're probably introducing extraneous roots. So we have to go back and look. What is the sine of 0? Sine of 0 is 0. The cosine at 0 is 1. And 1 minus 1, or 0 minus 1 is not 1. So that one is an extraneous root. Let's try at pi. Let me erase this, redo this at pi. So the sine at pi is 0. The cosine at pi is negative 1. And that one works, so I'm going to circle that and put a happy face by it. And let's try it again at pi over 2. At pi over 2, the sine is 1 minus 0. That seems like that's a happy place. And let's try it at 3 pi over 2. The sine at 3 pi over 2 is negative 1 minus 0, and that one does not work. So I'm going to cross that one out. So again, we did get extraneous roots on half of them, and we got 2 that worked at pi and pi over 2. But the moral of the story is one way to find these answers is to square both sides and simplify. Hey, I bet you they got the same answers. Extraneous roots, extraneous roots. All right. So let's have you guys try some of these examples, and I may make a video if you guys talk to me and want some more videos of a specific type. And I'll probably make a second video with some of these that are reciprocals and some tans.